Okay, this is part 156. This is line 18A, 3z2b5 Americium Alpha Decay Neutrinos split 4 Quarks U238 PU-BE5G UFO Wow Seti. Here's our Wow Seti alien radio signal. And here's the word Americium. That's Americium. I'm not sure how to say it. Oh, Americium. Never mind. A transuranic radioactive chemical element that has the symbol AM and atomic number of 95. This is what it looks like. It says in chemistry, transuranium elements, also known as transuranic elements, are the chemical elements with atomic numbers greater than 92, the atomic number of uranium. None of these elements are stable, and each of them decays radioactively into other elements. February 26, 2012, my thoughts. If you take the Americium plus the alpha decay mixture with neutrinos, this will equal neutrinos split into 4 quarks. Do this 5 times to equal 20 quarks from the neutrinos, plus excite with the formula equals the 5G UFO engine speeds plus 3 days from Earth to Mars travel time. I calculated the amount of speed that we would travel and how fast, and we could get to Mars in 3 days time if this formula works. If all these formulas work that I've blogged you about in all the videos, we should be able to get to Mars in 3 days time instead of 17 months is what the Mars 500 is estimated to get there with the technology we currently have at this time. So here's a quote. The alpha decay is one, actually sorry, it was either 3 days or 2 months. I had it down to 2 months, and then I tried to, it would be 2 months with just the actual formulas that I've come up with. That will take us 2 months to get to Mars. But I'm trying to get there within 3 days if possible. And this is the only way we'd be able to do it. My calculations could be off, but at least it gets us there quicker than 17 months. So, the alpha decay is one example type of radioactive decay in which an atomic nucleus emits an alpha particle and thereby transforms or decays into an atom with a mass number 4 less an atomic number 2 less many other types of decays are possible. Quote, the mass number A, also called atomic mass number or nucleon number, is the total number of protons and neutrons, together known as nucleons in an atomic nucleus. I always look up words that I don't understand, so I had to look up and see what alpha decay was all about. So that's what this is. Because protons and neutrons both, I'm going to be giving you another formula, so stay tuned. Because protons and neutrons both are baryons, the mass number A is identical with the baryon number B, as of the nucleus, as of the whole atom or ion. The mass number is different for each different isotope or a chemical element. This is not the same as the atomic number Z, which denotes the number of protons in a nucleus, and this uniquely identifies an element. Hence, the difference between the mass number and the atomic number gives the number of neutrons. N is a given nucleus, so it equals N minus Z. For example, uranium-238 usually decays by alpha decay, where the nucleus loses 2 neutrons and 2 protons in the form of an alpha particle. Thus, the atomic number and the number of neutrons each decrease by 2. And there's the calculations there. So that the mass number decreases by 4. The result is an atom of thorium-234 and an alpha particle, which is 4, 2, He2 plus that. So we got, there's the calculations right there, what it creates. On the other hand, carbon-14 naturally decays by radioactive beta decay, whereby 1 neutron is transmuted into a proton with the emission of an electron and an antineutron. Thus, the atomic number increases by 1. So then, if you put the two together, it should be able to balance something out there. Well, the number of neutrons decreases by 1. The resulting atom is nitrogen-14, which was 7 protons and 7 neutrons. So I'm saying if you can split them into this nitrogen-14, take these 7 protons, 7 neutrons, and split them by colliding them, you should be able to double up all your stuff quite quickly, your particles. Another type of radioactive decay without change in mass is number is emission of a gamma ray from a nuclear isomer or metastable excited state of atomic nucleus. Since all the protons and neutrons remain in the nucleus unchanged in this process, the mass number is also unchanged. Again, that's under mass number on Wiki. So February 26, 2012, my thoughts. Based on the data above, try mixing all of these together and see what you get for neutrino speeds when collided with a laser beam of light using obsidian mirrors or glass in your tests at CERN and other facilities conducting these type of experiments, like BELLE. Then the two of you need to compare your notes. Again, take a look at the height above sea level and see if the higher you go, the better the results. The neutrinos like to mimic other particles. So if you have 3 of them that alpha decay each, and every particle neutrino will mimic that which is closest to them, by splitting them into 4 quarks and 7 protons and 7 neutrons each, then accelerate the excited neutrino mixture to see what speeds you get. I would think it will go faster than the speed of light, and it can possibly reach the 5G in speed with the right calculations applied to it. You decide. Here's the formula for CERN to try with the neutrinos experiments if possible. Okay, so you got Americium plus your alpha decay plus the Z boson plus uranium-238 plus thorium-234 plus carbon-14 plus electron short pulse activates plus electron plus antineutrino plus thermal equilibrium plus an atom plus nitrogen-14, which brings you to the 7 protons and 7 neutrons, plus the gamma ray, plus the nuclear isomer, plus metastable excited state of an atomic nucleus, plus unchanged mass. This is the full formula to try if you can base on all the keywords jumbled together to formulate a new idea. So these are all the keywords that came up with this section here. So we're going to see if we can throw it all together. Okay? So we're going to take the use of fiber optics. We're going to add Sprite Twist PP. We're going to add rotating particles, plus neutrinos, plus lepton, plus protons, plus neutrons, plus the collisions, plus your obsidian blue glass sphere, plus the Americium decays radioactively into other elements. See formula above for this one. So you would add this formula plus this formula. Plus the neutrinos split into 4 quarks, plus short pulsed electron laser beam, plus low gamma ray intensity, plus excite neutrinos, plus liquid argon gas, plus your magnesium-238, plus uranium-238, plus lithium-7, plus boron-8, plus beryllium-7, plus borexno, plus plutonium-beryllium neutron, plus dissolved copper-64 positron, plus plutonium-beryllium neutron source, plus Pu-Be neutron source. And again, all these videos here, they all have different formulas in them that you'll be trying. And each time I do a formula, there's going to be more stuff added to it as I go along. We are on line 18A. I have from lines number 1 all the way to 27. And we're on number 18 at 18A. And line 18 goes all the way from A to Z. So this is, I'm still doing section line 18A. I'm not even done. Actually, I should be done probably when I get to line 18A5, and then we'll be going on to 18B after that. Okay, so this is the next video.